Hello students, welcome to my next video lesson. So in this video we are going to solve few questions based on capacitors. Hopefully you have understood the concept of capacitance. A capacitor is a device which holds a charge within it. It possesses an electrical energy, right? So in a practical arrangement we see that whenever two parallel plates having oppositely charged are separated by a finite distance small d, then they hold a charge between them. This charge or this electrical energy can be utilized in many applications. So you see, today we are going to solve few numerical questions where we will find that some capacitors are in series, some are in parallel, and their combination, that is complex network, how is to be solved, right? So in this question we have to find equivalent capacitance between A and B. In my previous video already I have told you that if the capacitors are connected in series, then equivalent capacitance is equals to the algebraic sum of reciprocal of individual capacitance. That means 1 by C equivalent equals to 1 by C1 plus 1 by C2 plus 1 by C3. Similarly, if capacitors are connected in parallel, then equivalent capacitance equals to sum of individual capacitors, that is C equivalent equals to C1 plus C2 plus C3 if they have three capacitors. So let us start our video today. You see in the diagram here 3 microfarad, 3 microfarad and 3 microfarad, they are in same branch. Therefore, all 3 microfarad are in series. So farad is the SI unit of capacitance, right? So all 3 microfarad are in series. Therefore, 1 by C dash equals to 1 by 3 plus 1 by 3 plus 1 by 3. LCM is 3. So in numerator also we will get 3. 3 and 3 will get cancelled, that is 1. That is C dash equals to 1 microfarad, right? Now this has been resolved into 1 microfarad. So if we redraw the circuit again, this circuit can be redrawn this is our A, this is our B, this is 3 microfarad, 3 microfarad, 3 microfarad, and this is 1 microfarad, right? This 3 has been resolved into 1 microfarad, and this is 2 and this is 2, right? Now this 1 microfarad is in parallel with 2 microfarad, right? This 1 microfarad is in parallel with 2 microfarad. That means C double dash will be 2 plus 1, that is 3 microfarad. Now once it is 3 microfarad, now you see this value is 3 now. Now this 3 and this 3, again they will be in series. Therefore, if I give here name C1 and this combination is being resolved into 3 microfarad, and let us consider this is C2. C1, C2 and C double dash are in series. I repeat, 1 microfarad per 2 microfarad, this will give 3 microfarad. Now this answer is in series with other 3 microfarad, right? So all the 3 are in series. Again, therefore 1 by C triple dash equals to 1 by 3 plus 1 by 3 plus 1 by 3, that is 1 microfarad. That is 3 by 3, 1 microfarad. That means C triple dash is also 1 microfarad, right? Now again, if you resolve the circuit, we will be getting like this. This is 3 microfarad, this is 3 microfarad, this is 2 microfarad, and this total again we have got here 1 microfarad, right? Again this 1 microfarad and 2 microfarad are in parallel. So 1 microfarad and 2 microfarad are in parallel. Therefore CO, let's change here, let's make it CO, that is 2 plus 1, that is 3 microfarad. Hence 1 by C equivalent. Now when this became 3 microfarad, now all the other capacitors are in series now. So 1 by C equivalent equals to 1 by 3 plus 1 by 3 plus 1 by 3, that is 3 by 3. You will get 1 microfarad, that is 1 by C equivalent, or if you cross multiply, you will get C equivalent equals to 1 microfarad. So this is our required answer, right? So let's see once more. So we need to solve this complex capacitance between A and B here. So first we will start from the innermost side, right? These three capacitors are in same branch, then we will consider they are to be in series. But if the current gets changed, then we will consider that that capacitors or that resistances are in parallel, right? So this combination we got here 1 plus 2 3. Now these 3 and these other 2, they are in series. Again 1 by 3 plus 1 by 3 plus 1 by 3. Again we will get here 1. So again plus 1 plus 2, we are getting a 3. At last 1 by 3, 1 by 3 and 1 by 3. So our net capacitance between A and B is 1 microfarad. So on this screen you can see I have drawn one network of resistances. Here these resistors, that is P, Q, R and S, they are arranged in such a way that no current passes from B to D, right? I repeat. So while solving any equivalent resistances or capacitance, if you see there are 5 electrical components, whether it be 5 capacitors or 5 resistors, then we will see that whether it is fulfilling this Wheatstone bridge condition or not. Okay, so let's see what is Wheatstone bridge condition. You see this network is connected with one battery having 3 volt, let us consider. So from the positive terminal of this battery, current will get emerged, and at this point of A, some portion of current will pass here, let us consider that is I1, and if the total current is I, then some portion of current will depart here, that is I minus I1, right? I repeat, total current is I here, at point A it will get splitted. So if I consider I1 amount of current is passing through P resistor, then I minus I1 current will be passing through AD, right? Now in this condition it has been found that potential developed at point B and potential developed at point D, they become same. That means VB equals to VD. Now we know if their potential is same, then no current passes through that branch. For measuring the current, we have placed one galvanometer to see that whether there is any deflection of current or not. So we have found that galvanometer is showing 0 deflection. This indicates that in Wheatstone bridge condition, when these 5 resistors are connected in such a way, the potential at point B and potential at point D becomes same. So as the potential becomes same, so no current passes through this resistor, that is 5 ohm. So if no current passes through this 5 ohm, then we can neglect this, right? So this circuit can be redrawn into we can redraw this circuit here. If I consider this one P, Q, R, S, right? Now one more thing, how you can find that no current is why these potentials are same. We can say that this potential same if P by Q is equals to R by S. Okay, so if their ratios are same, then we say that B and D both are at same potential. Okay, keep it in mind. Let's see what is our P. P we have 2 ohm, Q we have 4 ohm, R we have 6 ohm, and S we have 12 ohm. Now that is 1 by 2, 1 by 2. That means their ratio is same. So if P by Q equals to R by S, if their ratios are same, then we can say that this point B and this point D, they are at same potential and no current is passing through 5 ohm. So this 5 ohm can be neglected. So when we neglect this 5 ohm, then we will get the circuit. We can redraw the circuit same here like this. So you see now same current is passing here I, and if I minus I1 current is passing here, then here I1 current is passing here. Now same I1 is passing through this resistor also. I minus I1 current is passing through this resistors also. That means these two resistors are connected in series, and R and S, they are connected in series. Then their answer, again this circuit can be redrawn into this way, P by Q, R by S. Now you can easily find the equivalent resistance between the network, right? That means P and Q, they are in series, that is P plus Q, and R and S, they are in series, that means R plus S, and their equivalent capacitance we can find it easily, right? So if I place the value here, if I place the value of P, that is 2 ohm, and Q as 4 ohm, here 6 ohm and 12 ohm. Now if it is asked what is the equivalent capacitance between these two terminals, then we say that 2 plus 4, that is 6. If I consider this one as 6 ohm, 6 plus 12, that is C dash is 18 ohm. Now this combination and their combination in parallel, that is 1 by C equivalent equals to 1 by 6 plus 1 by 18. So LCM is 18, 3 plus 1, that is 4 by 18, that is 2 by 9 or 4.5. If we reciprocal here, then we will get C equals to 9 by 2, that is 4.5 ohm, right? So this was our answer. Now you see, after understanding the Wheatstone bridge condition, same question we get in case of capacitors also. Okay, so let's solve one question based upon Wheatstone bridge. So in this screen you can see that there is a network of 5 capacitors, C1, C2, C3, C4 and C5, right? Now these 5 capacitors are arranged in such a way that we have to check first whether they are fulfilling the Wheatstone bridge conditions or not. All the capacitors have a capacitance of 20 microfarad, and these capacitors are arranged in such a way that they are connected like a bridge. This C5, you see now, C1 is 20 microfarad, C2 also 20 microfarad. Now 20 by 20, that is 1. This is also 20, 20 by 20, that is 1. That means P by Q equals to R by S. It is fulfilling that condition. So we say that potential at this point, let us consider this is C, this is D. Potential at point C and D, they are same. Now we know if the potentials are same, no current flows. Current flows only when there is a difference in potential, right? So as no current is passing through this branch CD, so this C5 can be neglected. Now this circuit can be redrawn into in this way, right? So this is 20 microfarad, 20 microfarad. Okay, this is A and this is B. Now 20 and 20, they are connected in series. So 1 by C dash equals to 1 by 20 plus 1 by 20, that is 2 by 20, that is 1 by 10, or C dash equals to 10 microfarad. Now similarly, these capacitors and these capacitors, they are also in series. So when you solve C double dash, here also you will be getting 1 by 20 plus 1 by 20, that is 2 by 20, that is 1 by 10, or C double dash equals to 10 microfarad. Now their answer and this answer, they are in parallel, and we know if they are in parallel then they have to be added directly. That is C equivalent equals to 10 plus 10, that is 20 microfarad. Okay, so this was our answer. So this Wheatstone bridge condition also it is being used to find the unknown resistance. Okay, so if the resistors are connected in form of Wheatstone bridge, then we can find the unknown resistance also, and if the total capacitance also given in the question, then we can find the unknown capacitors also. Okay, next question is, you can see C1, C3, C4 and C5, it is given 4 microfarad and the capacitance C2 is given 8 microfarad, right? In this question also we have to find the equivalent capacitance between A and P. So after substituting the value in the diagram, you see 4 ohm, or you can say 4 microfarad here, 4 microfarad it is capacitors. So the unit is microfarad here. If it was resistances, then we could have used ohm, right? 4 microfarad and 4 microfarad, and C2 is 8 microfarad. You see this, whenever the current passes here, few amount of or different amount of current comes here, that is I1. At this point again the current gets changed. That means we can say that these capacitors and this capacitor, they are in parallel, right? Now once the current passes here, the current at this capacitor and current at this capacitor, they are not same because there is a partition here. That means again the current is getting splitted up here. So we will say that this capacitor and this capacitor, they are in parallel. Okay, so at a point, at a joint, wherever the current is splitting up, then we will say that that two branches are in, the capacitors in that two branches are in parallel. Now if the same current is passing through same branch, then we will consider that capacitors are connected in series. You see, when current is passing through this branch, it is getting changed here, right? So this capacitor and this capacitor, they are in parallel or series parallel here, and this capacitor and this capacitor, they are also in parallel, right? So this circuit can be redrawn like this. See, by looking the diagram you can understand that they are same as like Wheatstone bridge. Okay, so here C4, C3, C1 and C5 is less than this C2. Okay, so C1, C3, C5, so all we have 4 microfarad, that means 4 by 4 will get 1, 4 by 4 will get 1. So you will say here C1 by C5 equals to C4 by C3. Therefore, they are in Wheatstone bridge condition, or you can say they are fulfilling the Wheatstone bridge condition. Okay, that is, no current passes through CD. So no current is passing through CD as they are in same potential. Hence C2 can be neglected. Now if we neglect this one we have 4 microfarad. This is also 4 microfarad, 4 microfarad and 4 microfarad, right? So 4. Now if I neglect this one, so in the next diagram we will be omitting this one, right? So if we omit this one, C1 and C5 they will be in series, and C4 and C3 they will be in series, and their combination will be in parallel. Therefore 1 by C dash will be 1 by 4 plus 1 by 4, that is 2 by 4 or half, or C dash equals to 2 microfarad. Similarly, if we solve for this one for C double dash, then here also we will be getting for 2 microfarad because the values are same. Now C dash and C double dash, that means equivalent capacitance of these two, C1 and C5, and equivalent capacitance of C1 and C3, they are the same. Therefore C equivalent will be 2 plus 2 microfarad, that is 4 microfarad, right? 4 microfarad is the answer. few questions I will be teaching you from the solved example, so it will save our time and we can conclude more questions, right? So you see question example number 51. From the given figure, find the value of the capacitance C if the equivalent capacitance between A and B is to be 1 microfarad. All the capacitance are in microfarad. That means you see figure number 1B26. This diagram is given in the question. Now the total capacitance of this circuit is 1 microfarad, right? And we need to find the value of this capacitance C, right? This one we have to find. Now if you see carefully, here we have 4, here we have 6, here we have 12. So these are in microfarad, right? So from the diagram you see C5 and C6, they are in series, okay, because they are connected in same branch. So 6 and 12, that is 6 microfarad and 12 microfarad, they are in series. So we will find 1 by 6 plus 1 by 12. So whatever answer we are getting here, that is in parallel with C7, okay. Now this answer means first 6 and 12 they are in series, so we will find this equivalent capacitance, then their answer is in parallel with C7. Now whatever answer we are getting in this loop, these are in series with C1, right? Similarly C4 and C3, they are in parallel, so directly we will be adding here 2 plus 2, 4. Now this 4 is in series with C2, that is having 8 microfarad, okay, that means 1 by 4 plus 1 by 8. Again this answer and this answer and this answer, they are connected in parallel, okay. So first we have solved this is in series with this one is parallel, their answer is in series with C2. Now this answer and this total answer, they are in parallel, right? Now their answer is in series with C, equals to 1 by 1, that is equivalent capacitance was 1, okay. You see right hand side, this question is being solved. 6 microfarad and 12 microfarad, they are in series. So if they are in series, that means 1 by 6 plus 1 by 12. So we will be getting here 4, that means 4 plus 4, 8. So this circuit has been redrawn into 8 microfarad, right? Similarly you see here C3 and C4, they are in parallel, that means if they are connected in parallel, then we have to add directly, that means 2 plus 2, 4. Now these 4 and 8, they are in series, that means 1 by 4 plus 1 by 8. So we will be getting here answer which are in series, right? Next you see this one capacitance as it is. Now if you see in the diagram, this 8 and this 1, they are in series. This 8 microfarad and 4 microfarad, they are in series, and their answers are in parallel, right? And whatever answer we are getting for these two portion, that is in series with C, that is equals to 1, because the equivalent capacitance is given 1, we need to find here C, okay. So while solving you will find, you see 1 by 1 equals to 1 by C plus 9 by 32. So this 9 by 32 is the answer of this loop. So 9 by 32 plus 1 by C equals to 1 by 1, because equivalent capacitance was given 1. So answer is 32 by 23 microfarad, okay. So this question also you will try at home, that is 101, okay. Answer is 9 microfarad. And 18 microfarad. There are two questions. Question number 102 also, answers are also given here. Similar questions just now we have seen in solved example, okay. 1 microfarad and 1 microfarad, they are in parallel, and again 4 microfarad, they are in parallel, their answer is in series with 8 microfarad, and these two are in series and their answer is parallel with this combination, right? So answer is 5 microfarad. So one infinity question is also there, you see hint is also given. So this question also you will see, question number 98. So last question, question number example number 38. You are given two plain metal sheets of mica K equals to 6, that is dielectric is given 6 at a distance 2 into 10 to the power minus 5 meter apart. Calculate the area of metal required to construct a capacitor of capacity 0.02 microfarad. You see, capacitance is given 0.02 into 10 to the power minus 6 farad, and you see distance is also given, distance between the two plates 2 into 10 to the power minus 5 meter. Dielectric is given 6. We need to find here area of cross section. We know formula capacitance between two parallel conductors A epsilon naught by D, but here in this question you see dielectric is also given, so we have to write A epsilon naught K by D. In order to find A, we have to cross multiply and substitute the value, you will be getting the answer. Okay, so similar type of questions also you will be practicing from your book. I hope you have bought your book, so start practicing the numericals also. So for this video only this much. So in the next class we'll come with new topic and new numericals. Till then, goodbye.